Hello, all. Thank you so much for joining us on this Friday afternoon. I'm Jen Jordan, and I lead content and thought leadership at Insight Partners, which includes the Scale Up AI conference coming up in just 3 short weeks on November 12th. As a preview to this amazing event, I'm excited to introduce this fireside discussion with Anjuna CEO Ayal Yogev and Insight Partners Managing Director Lonne Jaffe. During our session today, look below on the screen because we're pleased to offer you a 35% off virtual ticket for Scale Up AI. The code and the website will appear right here during the chat. With that, please welcome our speakers to the stage. Take it away, Lonne.
Hi, everyone. Welcome to this episode of Scale Up Soundbites. So I'm Lonne Jaffe. I'm a managing director at Insight Partners. And today we're going to be featuring Anjuna, which is one of our portfolio companies. They're a leader in confidential computing software. And Ayal, the CEO of Anjuna, is here with us. I've had the pleasure of serving on the board of Anjuna and working closely with Ayal for, I guess it was a little over 3 years now since Insight Partners' initial investment in the summer of 2021. And Anjuna is one of the strongest teams in the world with deep expertise around secure enclave technology and what's called confidential computing. So today we're going to dive into a bit of what their latest innovations mean for the future of secure computing, how they're partnering with companies like NVIDIA and the major cloud providers to make this all a reality. And so, Ayal, it's great to have you here. Let's jump right in.
Thanks for having me, Lonnie.
Yeah. So to start, let's just do a little bit of the backstory. Can you introduce yourself? Explain a little bit about what brought you to start Anjuna originally?
Yeah, happy to. So my background has always been enterprise security. I've been in enterprise security for about 25 years now. Crazy to say. And actually started on the public side. My background is I started in Unit 8200, which is essentially the Israeli equivalent of the NSA. That's where I got introduced into security. And after leaving, I obviously moved to the private sector, and most of my career has been doing product management in enterprise security companies. I was at Imperva for the 3 years leading to their IPO, and was lucky enough to be part of that IPO. I was at Lookout, which is a mobile security company. I then joined OpenDNS to run their product management team. We eventually got acquired by Cisco, and at Cisco, I ended up running the umbrella product management team, essentially the product management team for cloud security for Cisco. Moved back to the startup realm again as the VP of product of a company called SafeBreach. And then when we started in June, I basically got reconnected with my co-founder, Jan. And he's also has a history with the Israeli intelligence community. That's where we actually met for the first time. And he ended up going to Stanford to do his PhD with Professor Dan Boneh, who's probably one of the top cryptographers on the planet today. And Jan read into that concept of confidential computing. And he got super excited by the tech, and he reached out to me. And the reason I got super excited was that, what confidential computing is going to mean for the industry. And what I mean by that is the best security solutions were always enablers, meaning they gave you the trust and the confidence to do something that you couldn't do before. And there's a lot of examples, but probably one of the best ones is the firewall, right? The reason why the firewall became so successful is that it gave organizations the trust and the confidence to connect their internal networks to the internet for the very first time. And obviously that became a huge deal. Another really great example is HTTPS. I'm sure a lot of the people watching this remember that probably 5-10 years ago, you would never think about sitting at an airport or a Starbucks and connecting to your bank account or connecting to your corporate email. And people can do that now without thinking twice about this because everything is encrypted from your browser all the way to the server using HTTPS. And confidential computing is the next big enabler. And what essentially it enables is collaboration. I'll talk a little bit about this, and obviously it has a lot of implications on AI as well. But there was such a big shift in the industry that I was sort of excited enough to say, okay, we have to jump in and do this.
Yeah, it's great. So let's get into it a bit. I think there's been a huge build out in the hardware associated with secure enclaves. AWS Nitro, the AMD chipset, the Intel chipset, and that hardware technology that's being provided by the hyperscalers, and then the new NVIDIA capability feels like it's kind of a substrate that that the software runs on. But maybe you can talk a little bit more about what Anjuna, the software product, does exactly, and what does it unlock on top of the underlying hardware?
Yeah, happy to. So you're absolutely right. There's been a huge shift on the hardware side of things, and as well as in with the hyperscalers, with the cloud providers, and at a very, very high level. As if I kind of take a step back and think about what confidential computing enables, as I mentioned, is collaboration. And what I mean by that is that you have essentially every application has three components, right? You have the code, you have the data that the code is running on, and you have the infrastructure that all of that is running on top of. And every time you have more than one entity involved in that, you run into a security or a privacy issue. And that's why the cloud was so scary to a lot of people, because you're saying, somebody else is running my infrastructure, can they have access to everything I do on top of that infrastructure? We're obviously seeing this in a big way in AI with, if I want to use somebody else's model, can they get access to my data running within that model, right? So we're kind of seeing this over and over again. And what the hardware vendors, the silicon vendors have done is essentially try to solve that problem. And you kind of needed the hardware vendors to do this because it's not a problem that can be solved with software only. And what essentially happened was the hardware vendors have all built something called confidential computing into their silicon to at a very high level do two things. One is protect the code and the data itself while the application is up and running, which has always been sort of the missing piece of this. And the other thing is something called attestation, just the ability to know the code and data haven't been tampered with. And that's been across the board. So Intel has done this, and AMD and NVIDIA and ARM and all the hyperscalers have added support for this with, the major one is that we're starting to see the smaller ones supporting this as well. And where we come into this at Anjuna is every time we see a shift like this in the hardware architecture, we essentially need a software stack on top of it to enable it and to make it easy to use and make it ubiquitous across the different players. And maybe the best previous example of this was what VMware did to virtualization. Right, virtualization was not invented by VMware, right? It was part of the silicon and part of the operating system. What VMware did was build a software stack to make it just super simple to virtualize everything. And now everything is running in a virtualized environment. And to some extent, this was the birth of the public cloud as well. We just wouldn't have a public cloud without virtualization. And Anjuna does the same for confidential computing. It's there in the chipset, it's ready to use. All the clouds are offering this, but it's extremely difficult to do this without a software stack to make it simple and ubiquitous across the different offerings.
Yeah, my understanding about some of the challenges that people were facing that led them to explore confidential computing is that, like, if you run something in the cloud, you can keep your data encrypted when it's on disk, but when it's just running in an application, it's just in the memory, and employees of the cloud vendors could do a memory dump. There's a level of security that's missing, and then the secure enclave technology solves that. But that if you the typical way of using it, you have to rework your application a huge amount, which is a big problem. It just it's a lot of work to redo the application to take advantage of the hardware. You start to get tethered to a specific platform, and sometimes you take a performance hit. And Anjuna is kind of riding to the rescue and solving all three of those problems, right? So you're able to move to the cloud and run on secure enclaves without reworking your application, mitigates the performance hit, and it keeps you abstracted away from a platform independence perspective and allows you to do excellent communication between different secure enclave environments.
Yeah, that's 100% right. If you kind of look at and you kind of touch on two very, very important points here. One is the core of the problem has always been what's called the data and use security problem. And what I mean by that is, even if you encrypt everything at rest and you encrypt everything in transit, meaning you encrypt in your databases or your file system, you encrypt everything on the network, when an application needs to process data, it just has to decrypt the data and load it to memory to process it. And at that point, the data is exposed. And that's exactly kind of the root cause of this problem. And that's exactly what the CPU and GPU vendors, were looking to solve. So that they've all put this as part of their technology. But as you said, once they've done this, and again, the hardware vendors have never, or again, are usually not, they kind of put this out there and then they rely on partners to help them enable this to some extent. That's why Intel worked so closely with Microsoft to build an operating system to enable the use of the 8086. And that's what we've seen NVIDIA kind of, using CUDA as a software enabler for access to their GPU. So we've kind of seen this over and over again. And the hardware vendors have put this out there to use, but that's exactly the kind of problems what you mentioned companies ran into is it was very, very difficult to use. And you had just the the need to rebuild every application for this new runtime environment was a very high bar, to close to impossible for a lot of people, and it was very hard to do so. Even if you did, manage to do so, you had to do different things for each environment, and not just each hardware environment, each one of what the clouds have provided, because you wanted to connect to the Kubernetes service or connect to the key management service. You needed to do different things. So it became this sort of insane matrix of, hardware support and, which cloud you're on, or if you're on-prem. So that was hard. And even once you've done all that, in many cases, people ran into a performance problem, because if you're not an expert in this, you might get yourself in trouble in terms of the performance of this, or even the security of this. Because if you're not doing this right, you're gonna, you might break the security model. And that's exactly where we come in to provide a software stack on top of this, just make it super simple to use, make it look the same across everything, do it in a performant way and in a secure way.
Great. So you have this core platform, I'll call it Anjuna C-Glass, which seems like it'd be sort of an obvious thing to do, to run underneath a database or a vaulting technology, or really any runtime system that you might have otherwise run on premise, because you are worried the cloud is not secure enough, or many other types of use cases. And then you recently launched this new product that you're calling AI Clean Rooms. Can you talk a little bit about what gave you the idea for that, and what is it exactly, and how does it differ from clean rooms that have existed in the past?
Yeah, definitely. So yeah, as it's kind of the first product we brought to market was what we call the Universal Confidential Computing Platform, and we call it our platform C-Glass. And yeah, we saw a lot of use cases, right? We're working with large banks to move things to the cloud that they couldn't do before. We're working on there's a bunch of different use cases that we've seen. Protect key material, running key management solutions inside of this. But one of the things we started seeing more and more were customers. I'll give you a few examples. Were essentially customers using this to build what essentially was an AI data clean room. And I'll give you one example. Working with essentially a top 10 bank, one of the largest banks in the world. The issue that they had was, like any bank is essentially is issuing credit cards to its customers. And as part of their offering, they want to do cashback deals to customers. And the problem there, and I'm sure a lot of our listeners have kind of experienced the same thing, that the problem with the cashback offers that you see is that you can get 10% off of Starbucks or Target or whatever it is, but the problem is the bank doesn't see what exactly you're buying at Starbucks or at Target or at whatever merchants you're using. And the merchants don't want to share that data, because that's proprietary data to them that they own, and it's it's part of their value prop. They don't want to share that with the bank. And that means that the offers that the bank is making are not as good as they could be, right? If they know me and they know that I like to buy a specific, cup of coffee at Starbucks every Thursday morning, they can make much, more targeted offers. And it's great for the customer because the customer is getting better offers. It's great for the merchant because it increases the utilization. It's obviously great for the bank. But again, the data sharing became an issue. And as I said, this is essentially enabling collaboration. What that bank did was essentially use our platform to build this sort of data clean room where the merchants can put their data in, and basically the bank can then use that to provide better offers for their customers. So just a phenomenal use case. And we started seeing that use case being used more and more, to the point that we said, we can leverage our platform to essentially make it easier for customers to go leverage this. Again, this very large bank, again, being a top 10 bank, can build something and kind of use their development power to go do this. But there's a bunch of other customers who are not as, who don't have the same level of resources. So we essentially build a data clean room, an AI data clean room product. Again, happy to share some of the use cases we've seen, but just super interesting things that we see people use this for. And as you would imagine, just because of the level of excitement around AI and the value of the data around AI, we just started seeing more and more AI use cases around this.
Yeah, very interesting. I feel like we've come across within our own portfolio, but also as we talk with customers in the Ignite program, a lot of scenarios where you either have multiple parties who want to pool data together and do analytics, but they don't want to share it with each other. They just want the resulting analytics to exist or the AI to exist. And similarly, you have situations like what you were describing, where you have maybe a single company that needs to pull in information from its customers, doesn't really want the raw data from its customers or partners, but needs to do some work on it, right? Fraud detection, cybersecurity, various types of analytics. There's healthcare scenarios, there's ad tech scenarios, there's a lot of financial services scenarios where you want to pull data together and do work on it, but you don't want the raw data and definitely don't need it. Are there
100%.
other types of customers or scenarios that the kind of broader platform would be used for? Like I'm thinking, SaaS applications that want to have an ultra secure version of their product, or databases where they want to have the like industrial scale, very secure version of the database, or vaulting technologies, other things that you're seeing customers use the overall platform for in the real world.
Yeah, yes, let me kind of actually dive in a little bit into some of the use cases we're starting to see with the data clean room, and then talk about this as well, because they're both kind of super interesting, and I think it's sort of a shift that's happening, and to some extent they feed each other, which was very interesting for me to see.
Yeah.
So again, I mentioned the kind of that bank use case with the with the working with the merchants, but we see again. You mentioned collaboration, working with insurance companies. So actually, 3 insurance companies, they wanted to share data to do anti-fraud detection, and but they don't want to. They don't want to, and are not essentially allowed to share data with one another. So putting this in an AI clean room, being able to do anti-fraud detection in this protected environment without anybody seeing anybody else's data, was one use case. You mentioned healthcare, working with a healthcare company. They have a lot of patient data, which is obviously extremely sensitive and extremely regulated. But there are all these companies popping up with new AI models to do things like early cancer detection, which again is great, and that company wants to use these models, but they're running into essentially a regulatory block in terms of being able to use that data within those platforms because of how sensitive that data is. And these companies don't want to take the model and run it within the healthcare provider, infrastructure, because it's their IP. They're worried about their IP. So again, having this sort of data clean room where you can put the model in, you can put the data in, you can run them together, get the results, and nobody sees each other code and data, is something that we've seen. We're seeing it in manufacturing, working with a large manufacturing company, and they basically want to get data to improve their own processes, but their customers don't want to share that data with them because the failure rate, as an example, they have very large public companies as customers, and the failure rate could impact the stock price. It's data that they're not allowed to share with the manufacturer. So being able to get the data that they need out to improve their processes without getting any of the data that their customers don't want to share is another very nice use case that we're seeing. But as you're mentioning, what we're starting to see as well with SaaS vendors, and again, it's true with databases, but just SaaS in general, if we kind of take a step back, a lot of SaaS companies are running into this sort of security, audit when they sell to customers, because customers are worried. They're saying, if I'm using SaaS, you essentially have access to all my data within your platform, and that becomes a risk. When they use confidential computing, essentially it allows them to protect the customer data at the point that they don't even have access to the data. They can provide the service, they can run whatever they want inside of it without them actually having access to the data. And when it comes to databases specifically, this is extremely powerful, because what we sometimes see with customers is that they encrypt the data on the client side before it goes into the database, because they're worried about the database company potentially having access to the data. The problem with that is that then the database company doesn't have any, hurts the functionality of the database, because the database itself can't see the data. So there's specific things the database won't be able to do. With
like
confidential
certain types of
computing,
query optimization, or there's a lot of metadata that the database picks up from the underlying information that it uses to optimize itself. So if it can't see, that can be a challenge.
exactly. So you lose all that functionality, and with confidential computing, that whole problem goes away. The database itself sees the data, but no employee of that company, nobody outside that protected environment sees the data. So
Yeah.
it provides a really, really nice way of doing this.
Yeah, that the ability to take existing database workloads and kind of run them as is in a place that's much more secure. I feel like there's a lot of data that's been stranded in various on-prem systems, and modernization that hasn't happened, that this could unlock now that confidential computing hardware is built out and Anjuna exists. So as you're looking ahead to 2025 and beyond, one of the things that I have been paying attention to most closely is this partnership with NVIDIA that's starting to play out. I had one company, Deci AI, that got acquired by NVIDIA earlier this year that I'm on the board of. I was on the board of, and Run AI, which I'm on the board of, that had an announced acquisition by NVIDIA. That one's not closed. So I've been following this partnership with great interest. Can you talk a little bit about that and how secure enclaves relate to GPUs and all the exciting Gen AI build out, and then also some of the other cloud providers like AWS and Azure and Google Cloud?
Yeah. So as you mentioned, we have a partnership with NVIDIA, and obviously we have a partnership with the cloud vendor as well, with AWS and Azure and GCP. And the focusing on the partnership with NVIDIA, as I mentioned, hardware vendors always needed a software stack on top of this on top of their solutions to enable them. So to some extent, the fact that we're making confidential GPUs extremely easy to use is kind of the value prop and how we work with NVIDIA. There's an extra layer of need here for something like this, because essentially any AI workload you run starts on the CPU and obviously moves to pieces move to the GPU for optimization. Confidential computing, there's an attestation piece. Basically, what happened is the CPU and the piece running on the CPU and the piece running on the GPU need to authenticate each other to make sure that you're not passing the data to something that shouldn't have access to the data. So a software stack that makes it essentially easy to use both the CPU and the GPU is required here. If you're starting to run on AMD and then you want to move to an NVIDIA GPU, you need that cross attestation. And for customers to build themselves is essentially close to impossible. And that was kind of what got NVIDIA to start working with us, is just seeing how easy and how simple we make this, where everything is sort of protected end to end. The reason why the clouds are working with us is we essentially make it easy and secure to move things to the cloud. So again, the cloud's kind of like what we talk about SaaS vendors. The cloud can tell their customers, when you use confidential computing, we just don't have access to anything you do on top of our infrastructure. So there's no barrier into moving essentially anything to the cloud. And I guess one sort of interesting thing to talk about here, especially relates to the NVIDIA relationship, is we've been kind of public about one of our joint customers, which is the U.S. Navy. That is, and I'll kind of share what I can as part of this. They basically have, every U.S. Navy ship is essentially its own mini data center. And obviously there's a bunch of GPUs on the ships. Currently, because the data that they collect is extremely sensitive, they send a lot of that data to shore. But with the right level of privacy, they can do a lot of the inferencing on the ship itself. But again, they need that layer of protection because the ships are out there in the world. You don't know who might potentially get access. You want to make sure it's secure enough so that even if the wrong person gets physical access or the root access, they can't access any of the data or the code running on top of it. And that's exactly what confidential computing provides.
Yeah, it's very interesting. I think people who are familiar with confidential computing and think of it as like a runtime platform, that you run applications on, like almost like an app server, underappreciate both the data aspect, the data platform aspect, as well as the communication aspect. Like you can run things in secure enclaves on a ship or in one cloud, and then have another secure enclave environment in another cloud, and they basically can have this like incredibly protected, encrypted tunnel between those environments in a way that isn't really possible to do and with other techniques. And then there's also like an interesting cost savings aspect, right? Like there's a whole bunch of existing cybersecurity product categories that you can just unplug and save money on once you're running things in the secure enclave.
100%. So one is, to some extent, once you run everything in confidential computing, then every data is never exposed, right? So you can take a machine, completely unprotected, no firewall, unpatched, connected to the internet. It's going to be crawling with hackers with root access potentially, but they're not going to have access to anything. So again, you can get rid of a lot of the existing security stack when you use this, because this is sort of baking security into the infrastructure. So the right way to the security versus all the kind of later patches that people put on top of this. And the other cost saving aspect to this is, because this is so secure, it allows you to take your code and run it anywhere you want. So a lot closer to the data. Again, very kind of going back to the Navy use, because that's exactly it, is running the code close to where data is being collected. And that also has a huge, cost saving aspect to it, as well as saving on latency, because you don't have to ship the code, you don't have to ship the data to the code. You can run the code close to the data.
Great. And I guess anything you can say about the future of confidential computing and the big picture about where things are headed? One thing that we see a lot of is companies who look at, say, something like large language models or foundation models from the frontier labs, and they're like, oh, this is very interesting, but I can't use it because my data is very important, right? So I can't send prompts or retrieval augmented generation data, or I can't fine tune a model because the thing that I would use is just too sensitive, and I don't have the infrastructure to run it myself. And even if I did, it wouldn't be secure enough. It feels like, especially with the new NVIDIA partnership on GPUs, we may be close to solving that problem. But curious to hear any other thoughts about the futures.
No, so 100%. This is exactly, again, as I said, this is enabling collaboration, right? And it's exactly kind of being able to use any model from anyone with regardless of how sensitive your data is. You can go use this without having to worry about this. You can run it on any infrastructure. You don't have to build your own. People basically, and we kind of see this, that in many cases, people are worried about moving things to the cloud or using somebody else's infrastructure. This enables you to run anything in any environment, right? To some extent, it potentially even opens up the door to leverage, if a large bank has excess capacity in their data centers, they can go lease it out. And today, they're never going to do this and nobody would use it. But with confidential computing, it opens the door to doing things like this. But if I kind of take a step back and talk about where this is going, I think confidential computing will become computing, meaning everything is going to be run this way. And we've kind of seen this in security over and over again. Again, the firewall is a great example, right? We started with firewall being used by the largest companies on the planet. But today, we're both kind of sitting at home connected to a firewall, and it's going to be crazy today to connect to the internet without a firewall.
Yeah,
so
like
any security technology,
HTTPS, nobody uses regular HTTP anymore, right?
Exactly. We've seen this definitely in encryption, right? HTTPS used to be just banks and these types of organizations. Today, any personal blog, any news website is using HTTPS. There's nothing sensitive on a news website, but it's a check. Like, why wouldn't you turn it on? It'd be crazy not to if it's easy enough to use and the performance impact is low enough or non-existent. We've seen the same with disk encryption, right? 5 years ago, no disk was encrypted. Today, you can buy a laptop without having disk encrypted by default. The only place where data is not protected today is memory, is in use. But it's now available in every chipset. The performance impact is extremely low because the hardware is doing all the heavy lifting. We and platforms like us make it extremely simple to use. So I think this is just going to become the default on how we run everything.
Well, this is great. Yeah, I can see all of that becoming increasingly salient, especially as we start to see generative AI-powered cyber attacks and just the threat landscape continue to evolve. Well, definitely keep an eye on Anjuna, and of course, make sure to join us at Scale Up AI 2024 later this year. We'll be bringing together more of the top AI builders and execs and CEOs like Ayal from all around the world. And thank you for joining us, Ayal, and thanks everyone for tuning in. Until next time.